Hello, my name is Bram Stelt, CEO of CleverIR. Today I would like to introduce you to a new and exciting application of our infrared sensor technology. Our infrared sensors are used in robotics to repair sewage without the need to dig up sewage pipes. And this has a big benefit for infrastructure projects all over the world. Throughout the world, infrastructure faces a number of challenges, not because of climate change, but especially because the existing infrastructure is outdated and has been allowed to deteriorate over the last 50 years. Combine this with the growing population that asks for additional capacity and the fact that existing infrastructures are wearing out at a higher rate, and you see that we are facing a vast problem. To give you some insight, let's look at the USA. The infrastructure receives an overall rate of D+ from the American Society of Civil Engineers. Grade D is considered to be poor and at risk, just one step above failing and unfit for purpose. Infrastructure entails a lot of things, amongst others sewage. And if we look at the whole world, the sewage infrastructure is expected to grow in line with the global population growth. Maintaining and updating sewage systems is essential. Dangerous substances, toxic chemicals, they run through the sewage systems, and when they leak out, they threaten the food and health security of the population. To give you an example, every day in the United States, nearly 6 billion gallons of clean, treated drinking water is leaking through damaged sewage pipes. This is 14 to 18% of the total volume of drinking water. And this is sufficient to supply 50 million households with clean drinking water every day. Despite sizable annual investments, there is still a huge backlog in sewer rehabilitation due to the aging infrastructure. Investments in the EU are expected to increase to 289 billion by 2030, according to the OECD. In Germany, it is expected that they need to invest 100 million in sewage rehabilitation. And if you look at the world at large, this number can be multiplied a couple of times. Luckily, there's also good news. The German company I.S.T, which stands for Innovative Sewer Technologies, has a wide product range for sewer rehabilitation. Their design team is continually focused at innovative technologies for sewage repair with the latest state-of-the-art sophisticated components and techniques. So let's zoom in on their state-of-the-art Trenchless, so no-dig rehabilitation solutions for pipeline repair, the double 6-core robot. It's not only a brilliant solution, but it's cost-efficient, environmentally friendly to repair existing but damaged pipelines. So let me explain a bit how this works. I.S.T's solutions have a UV liner that is impregnated with a resin which is curable under UV light. This liner is moved up into the sewage, into the section that is damaged, and it is pressurized to expand against the inner wall of the pipe. UV lights are entered into the liner and they illuminate the hose from within, creating a chemical reaction that hardens the resin. This is a process that needs to be monitored closely to guard the temperature. Temperature is important because if the resin gets too warm, if it's illuminated too long, it becomes brittle and it can break. If it's not illuminated long enough, then the resin will remain soft and it can also crack. So monitor this process with temperature is essential for a good solution. I.S.T uses the Exergen IRTC sensors to monitor the curing process of the resin. They selected the IRTC sensors from Exergen because they are very small, they are unpowered, so they don't need any power supply, and they are extremely durable, accurate and reliable. I.S.T relies on the information from the temperature sensor to make sure that the curing of the resin is exactly according to specifications to have the optimal results for the repair of the pipeline. If the temperature in this curing process is not monitored closely, so if the temperature of the resin is not according to specifications, there is a risk that the repair is not done successfully and that they have to do it again. And this of course adds the costs to the repair, it adds to the labor, and there is even a risk that they really have to do the excavation because they cannot repair the pipe from within. So for I.S.T, the Exergen IRTC sensor was the ideal solution for their problem. Of course they wanted a sensor that was small, accurate, durable and cost efficient, but on top of that they needed a solution that would withstand high ambient temperatures and was not sensitive to UV radiation. Conclusion: the Exergen IR sensor checks all the boxes for the requirements of I.S.T.